Today's video, I am going to discuss the moment generating function of binomial distribution, mean and the variance of the binomial distribution in this video. See here, first of all, the moment generating function of a binomial distribution, it is mx of t is equal to the expected value of e power xt. So this can be written as sigma x is equal to 0 to n e power xt into p of x. So according to the binomial distribution, so this can be written as sigma x is equal to 0 to n e power xt. So p of x can be written as this is ncx, this is p power x, and this is q power n minus x. And this can be written as sigma x is equal to 0 to n. So this is e power x and here also p power x. So if I club this, so if I write e power t power x and I write this p power x nearer, then this is ncx into q power, this is n minus x. A power m into a power n can be written as, so this is a power n into b power n can be written as ab power n. So I'm clubbing these two, that is sigma x is equal to 0 to n. This is e power t into p whole power x. This is ncx into q power, this is n minus x. So now this can be written as sigma x is equal to 0 to n. This is ncx e power t into p power x, and this is q power n minus x. And see, according to the binomial distribution, this can be written as p plus q power n. So here in place of n we have n minus x. So this is n. This can be written as, in place of p we have e power t into p plus q power n. So this is nothing but the moment generating function of a binomial distribution, which is equal to e power t into p plus q power n. See, let me explain you once again. See, the moment generating function of a binomial distribution is given as mx of t is equal to the expected value of e power xt. So in terms of sigma, it can be written as sigma x is equal to 0 to n e power xt into p of x. As you know that p of x, according to the binomial distribution, it can be written as ncx into p power x into q power n minus x. See here, there is e power x here and p power x here. So if I club these two, so if I write e power t power x and p power x, so what remains here? ncx into q power n minus x. So it can be written as e power t into p power x into ncx into q power n minus x. So if I bring it in the form of a binomial distribution, that is ncx p power x into q power n minus x. So this can be written as p plus q power n. What is in place of p? We have e power t into p plus q power n. So therefore, the moment generating function of a binomial distribution is nothing but e power t into p plus q power n. Now, we are going to discuss about the mean of the binomial distribution. See here. So the mean of the binomial distribution is nothing but, so according to our binomial distribution, we have p of x is equal to, this is ncx, p power x, and this is q power n minus x. And again, you have to keep in mind that is the probability of success plus probability of failure is always equal to unity. So p plus q is always equal to 1. So according to our expected value or the mean, so the mean mu is equal to e of x. The expected value is equal to, this is a sigma x is equal to 0 to n. This is x into p of x. So according to our formula, so this is x into p of x. So I am going to write this as sigma x is equal to 0 to n. This is x. According to the binomial distribution, this can be written as ncx. This is p power x and this is q power. This is n minus x. So as we have a formula that NCR is equal to, so this is the formula of writing, that is NCR is equal to n factorial by n minus r factorial into r factorial. So I'm using this. So if I use this, this can be written as sigma x is equal to 0 to n. This is x. NCx can be written as n factorial by, this is n minus r factorial into r factorial. and this is p power x, and this can be written as q power n minus x. Got it? See here, I want to cancel this x. So for that I'm doing, that is sigma x is equal to 0 to n. This is x, this is n factorial. See, x factorial can be written, x factorial is nothing but 1 into 2 into 3 into so on till n x. So I am writing this as x into, this is x minus 1 factorial into n minus x factorial, and this is p power x, and this is q power n minus x. Now I am going to cancel this x. So after that, this can be written as sigma x is equal to 0 to n. So I'm writing this in the form of n into, this is n minus 1 factorial, and see here. So, and again everything I'm changing in place of, so this is x minus 1 factorial, so I'm adding 1 and subtracting 1. This is n minus 1 minus, this is x minus 1 factorial, and again I'm writing this as x minus 1 into p power 1. So this can be, q can be written as, so this is n minus 1 into, this is x minus 1, if you observe this. So sigma x is equal to 1 to n. See here what I've done. So this is sigma x is equal to 1 to n. So this one is nothing but, so here the term n and p are the constants here. So I'm bringing it outside. So this can be written as n into p. This is nothing but n factorial by, this is n minus r factorial. So this is n minus r factorial into, again this is r factorial, and this is nothing but p power x into q power n minus x. This is n minus, this value is x. See here, n factorial, I wrote this as n into n minus 1 factorial. Clear? And next one, so this is x minus 1 factorial as it is. So in place of, in between n and minus n, I've added 1 and subtracted 1. Here this is minus 1 and this is minus of minus plus 1. So for my convenience, see here, I need n minus 1. So to adjust this one, this is n minus 1. To balance this one, I added 1. So this is factorial. So this can be written as p power x minus 1 plus 1. So here also I need n minus 1. So I'm subtracting minus 1 and again adding minus 1. So I wrote this in the form of n minus 1 minus of x minus 1. So this is nothing but n factorial by n minus r factorial into r factorial. So this can be written as, see here, so this can be written as, so this is n into p, this is ncr. So in place of r we have x minus 1. This is p power x and this is q power, this is n minus x. So if you compare with this, ncx p power x q power n minus x. So this can be written according to the binomial distribution as, see here, this is sigma x is equal to 1 to n ncr p power r q power n minus r. So this can be written as, this is p plus q power n minus 1. As you know, the p plus q, the probability of success and probability of failure is always equal to 1. So this is nothing but np into 1 power n minus 1 is again 1. So which is equal to np. Therefore, the expected value or the mean, so here the expected value or the mean of the binomial distribution is nothing but NP. So this is how we have to solve. This is also so simple if you follow these steps. So as you know that P of x is equal to NCX P power x into Q power n minus x, where P plus Q is equal to 1. So we need the mean of the binomial distribution. So expected value is equal to sigma x is equal to 0 to n x into P of x. As we have P of x as NCX P power x into Q power n minus 1. So again NCR can be written as n factorial by n minus r factorial into r factorial. So I use that formula, that is n factorial by n minus x factorial into x factorial. This is p power x into q power n minus x. So I want to cancel this x. So for that, in place of x factorial, I can write x into x minus 1 factorial, same as it is. So after cancelling this x, see here, sigma x is equal to 1 to n factorial can be written as n into n minus 1 factorial. See here, wherever I find n, I need n minus 1. So for that adjustment, so I have written this one, n minus 1 minus of x minus 1. I have subtracted minus 1 and added minus 1. So in place of p power x, so I added my minus 1 and plus 1. So here also minus 1 I've taken minus 1, and in order to balance this is plus 1, that is n minus 1 minus of x minus 1. So if you practice this steps, it will be very easy. And next one, the constants here are n and p. So after taking n and p outside, so what remains? N minus 1 factorial by, this is n minus r factorial into r factorial. This is p power x q power n minus x. So this can be written as ncr p power x q power n minus x. So according to our binomial distribution, it can be written as p plus q power n minus 1. So as you know that the total probability is always equal to unity, and therefore so p plus q is equal to 1, therefore np. Therefore the mu, the mean of the binomial distribution, or the expected value, is equal to np. Now coming to the variance of the binomial distribution. See here, the moment generating function, according to the moment generating function, so we have p of x is equal to, this is ncx, this is p power x, and this is q power n minus x. So we need the variance of the binomial distribution. So variance is nothing but sigma square of x is equal to e of x square minus e of x whole square. So we need to calculate that e of x square. So the expected value of x square we have to calculate. So in order to calculate this one, see here, I'm adding x and subtracting x. See here, I'm subtracting x and adding x. So this can be written as, see here, if I take x common from these two, this is x minus 1 plus x. And therefore, so this is nothing but x into x minus 1 plus the expected value of x. See here, first of all, I am going to calculate this e of x square. So e of x square, I have to calculate these two. First of all, I am going to calculate the expected value of x into, this is x minus 1. So x into x minus 1, so according to our binomial distribution, so this is equal to sigma x is equal to 0 to n. This is x into x minus 1 into p of x. As you know that p of x is equal to sigma x is equal to 0 to n. This is x into x minus 1. According to our binomial distribution, this is ncx, this is p power x, and this is q power n minus x. N minus x. So this can be written as sigma x is equal to 0 to n. This is x into x minus 1, and ncr can be written as n factorial by, this is n minus r factorial into r factorial. This is p power x, and this is q power, this is n minus x. And see here, I want to cancel this x into x minus 1. So from this x factorial, see what I am going to do. This is sigma x is equal to 0 to n. This is x into x minus 1. See here, x factorial can be written as x into x minus 1, and the next thing is x minus 1 factorial, and here it is n factorial, this is n minus x factorial. So this is p power x into q power, this is n minus x. Now if I cancel these two, so what remains here? So this can be written as sigma x is equal to 0 to n. So this is nothing but n factorial by, this is x minus 2 factorial into n minus x factorial. This is p power x into q power, this is n minus x. And see here, I need n minus 2 everywhere. So I am going to write this as, see here, this is sigma x is equal to 0 to n factorial I am writing. So I need minus 2. So this is n into n minus 1 into, this is n minus 2 factorial by See, n minus x. In between this one, I'm subtracting minus 2 and adding minus 2. See how this is n minus 2 minus this is x minus 2 factorial. See here, subtracting minus 2 and this is minus of minus plus 2. And this is again x minus 2 factorial. See here, in this case also, this is p power p to the power of x, this is minus 2 and this is again p square. And see here, in between n minus x, I'm subtracting minus 2 and adding minus 2. See how this is n minus 2 minus this is x minus 2. Got it? See here, these are the constants, that is n into n minus 1 and here this is p square. So if I bring them outside, that is n into n minus 1 into p square. See what happens. So this will be sigma x is equal to 0 to n. This is n into n minus 1 into p square. And what remains here? So this is n minus 2 factorial by this is n minus 2 minus x minus 2 factorial into x minus 2 factorial, and here this is p power x minus 2 and this is q power n minus 2 minus this is x minus 2. See, so if I send these 3 outside, so this will be n into n minus 1 into p square. This value is sigma x is equal to 0 to n. So this is nothing but n factorial by n minus r factorial into r factorial. So this can be written as ncr into this is p power r into q power n q p power x into p power n minus x. So according to our binomial distribution, so this is nothing but n square minus n into p square, and this is ncx p power x q power n minus x. If you observe this one, according to our binomial distribution, this can be written as p plus q power n minus 2. So as you know that the probability of success plus probability of failure is always equal to 1, and so I am writing this as n square minus n of p square into 1 power minus 2. So this is nothing but n square minus n into p square into p square. So this value is nothing but the expected value of x into x minus 1. And see here, the expected value of x into x minus 1 is nothing but n square minus 1 plus p of x. As we have the mean value, so the mean of the binomial distribution, just now I found this one. So this one, just I'll show you the mean. See here, the mean e of x is equal to np. So we have e of x value as np. Now, see here, we need e of x square. So e of the expected value of x square according to our formula is expected value of x into x minus 1 plus e power x. That is expected value of x into x minus 1 plus the expected value of x. See here, x into x is x square. This is minus x and plus x. So here x into x minus 1 value is nothing but, see, this value is nothing but n square minus n into p square. And here the value here is np. And see, if I multiply these two, so this will be n square p square. If I multiply, this is minus n into p square plus np. See here, this is n square p square. If I take np common from these two, this will be 1 minus p. So as you have that p plus q, the total probability is 1. That is, q value is nothing but 1 minus p. So now in place of 1 minus p, I can substitute, that is n square p square plus np into q. So this is nothing but e of x square. So now we need the value of the variance. So the variance of x is equal to sigma square of x is equal to expected value of x square minus e of x whole square. So if I substitute the same thing here, so what is this expected value of x square? So this is nothing but n square p square plus npq minus what is e of x? E of x value is nothing but np. If I substitute the same thing here, that is np whole square. So this is nothing but n square p square plus npq minus this is n square p square. So if I cancel this one, the value here is npq. Therefore, the variance of the binomial distribution. So the variance value is equal to npq. So this is how we have to solve, and this is also so simple if you follow these steps. And see, first of all, according to the variance of the binomial distribution, so we have p of x is equal to ncx p power x into q power n minus x. So according to our variance formula, this is expected value of x square minus expected value of x whole square. So first of all, I need the value of e of x square. So instead of finding straightly e of x square, so I am subtracting and adding x. So this can be written as expected value of x into x minus 1 plus x. So first I need this value. So in order to calculate this value, so this can be written as sigma x is equal to 0 to n x into x minus 1 into p of x. So as you know that p of x value is nothing but ncx p power x into q power n minus x. So ncr value is nothing but n factorial by n minus r factorial into r factorial into this is p power x into q power n minus x. So I want to cancel this x into x minus 1. So if I cancel this one, so x factorial can be written as x into x minus 1 into x minus 2 factorial. So I need minus 2 everywhere here. So in order to balance this one, see here, n factorial can be written as n into n minus 1 into n minus 2 factorial, and this is p power x minus 2 and this is p square, and q in between n minus x, I subtracted minus 2 and added minus 2. And see here, everywhere. So here, n minus 2 minus x minus 2 factorial. So this can be written as ncx p power x q power n minus x. So which is nothing but p plus q power x, p plus q power n. So here n value is n minus 2. 1 power anything is again 1. So this value is n square minus n into p square. So again we have the mean of the binomial distribution as np. So e of x square can be written as e of x into x minus 1 plus e of x. So the first value is n square minus n into p square, and the next value is np. So if I multiply this one, this will be n square p square minus np square plus np. So if I take np common from these two, so this is 1 minus p, which is equal to q. So we need the variance of the binomial distribution. So this is e of x square minus e of x whole square. So the first value is this one, the second value is expected value is np. So now we need np square. So after cancelling and solving, so we got the variance of the binomial distribution as npq. Thank you so much for watching, and this is the most important thing. And please pass it on if you really like. Please practice and subscribe to this channel. Please follow my playlist, and it will be very useful for your preparation. Thank you so much.